Hello, science fans! Today, we're diving into nuclear science, a topic that sounds intimidating but is actually fascinating and vital to our lives. When you hear nuclear, you might picture dramatic movie scenes or complicated news stories, but nuclear science is everywhere, from powering cities to medical imaging. Our goal? To break down these big ideas into simple, bite-sized pieces. Once you know the basics, the whole subject becomes much less mysterious. We'll demystify nuclear terms so you can understand the headlines and have informed conversations. To guide us, we have Professor Dr. Ali Abdou, a leading nuclear engineer and passionate science communicator. He spent his career making nuclear science accessible to everyone. By the end, you'll see that nuclear terms aren't just for scientists, they're for all of us. Understanding this language helps us make sense of the world and separate fact from fear. So let's get started. Your journey into the world of nuclear science begins now. Consider this your invitation to explore with us. Meet Professor Dr. Ali Abdou, our expert guide in nuclear engineering. He's spent years researching, teaching, and working in the nuclear industry, blending academic knowledge with real-world experience. Professor Abdou has contributed to nuclear power generation, safety, and technology applications. What sets him apart is his talent for making complex science clear and relatable. He believes science should be accessible to everyone, not just experts. By bridging the gap between scientists and the public, he helps us all become more informed. His dedication to clear communication makes him the perfect guide for our journey. Let's learn from one of the best in the field. Why does nuclear language matter? Because words shape how we think and feel about nuclear science. Misused terms in news or movies can create confusion and fear. Understanding the difference between nuclear energy and nuclear weapons is crucial, especially in today's world of energy debates and security concerns. If we don't know the basics, it's hard to follow important conversations or spot misinformation. In regions like the Middle East, a single misunderstood word can fuel anxiety and impact policy. Clear, accurate language helps prevent misunderstandings and promote stability. Just like a doctor explaining a procedure, precise terms make us feel informed and empowered. By learning the right terminology, we take control of the narrative. We choose facts over fear. And that's essential for global conversations about our nuclear future. Knowledge is power, especially when it comes to nuclear science. Let's clear up some common nuclear confusions. First, nuclear energy versus nuclear weapons both use nuclear reactions, but a power plant is like a controlled campfire, while a weapon is an uncontrolled explosion. Nuclear reactors are built for safety, releasing energy slowly to generate electricity. Next, uranium enrichment. Natural uranium has different isotopes, but only U-235 is useful for chain reactions. Power plants use uranium enriched to about 35% U-235, like making coffee a bit stronger. Weapons require over 90% a super-concentrated espresso. The technology may overlap, but the goals and enrichment levels are vastly different. Now, radiation versus radioactivity. Radioactivity is an unstable atom's potential to release energy. Radiation is the energy released when it decays. Think of a popcorn kernel, radioactive, and the pop, radiation. We encounter natural background radiation daily from the sun, even from bananas. Knowing these distinctions helps us interpret news and understand real risks. These aren't just scientific details, they're keys to understanding our world. The more we know, the better we can separate fact from fiction. The words we use in nuclear science matter. They shape understanding and public reaction. Science communicators like Professor Abdou and platforms like Salah Lotfy make complex topics accessible and engaging. In a world flooded with information, clear science communication helps us make informed decisions. It encourages curiosity and critical thinking, essential for today's challenges. Especially with sensitive topics like nuclear technology, clarity lowers fear and raises the quality of public debate. Educators provide the facts, not just opinions, so we can build a solid foundation for discussion. A well-informed public is crucial for a healthy society. Science is for everyone. It's our shared adventure to understand the universe. Thanks to those who make science clear, we're building a smarter, safer, and more curious world, and that's something to celebrate. Nuclear power, fascinating, powerful, and sometimes misunderstood. We hear about reactors lighting up cities and bombs causing devastation, but they're worlds apart in how they work. Both use uranium, but the difference is control, like a campfire versus a wildfire. Today, we'll explore what makes a reactor a steady energy source and a bomb a weapon of destruction. We'll dive into the science of uranium chain reactions and how energy is controlled or unleashed. Think of uranium as a special ingredient prepared one way, it powers cities another, it creates explosions. To guide us, we have Professor Dr. Ali Abdou, a nuclear engineer who knows how to turn atomic science into safe, useful energy. He'll help us break down complex ideas like why a power plant can't become a bomb and how leftover materials are managed. We'll cover isotopes, enrichment chain reactions, and safety. By the end, you'll understand the real science behind the headlines. You'll be able to explain the difference between a controlled and uncontrolled nuclear reaction. Science is the key to understanding our world, and nuclear science is a powerful part of it. Ready to explore the atom's secrets? Let's get started. To truly understand nuclear engineering, we turn to Professor Dr. Ali Abdou. He's a leading expert dedicated to making nuclear energy safer and more efficient. Dr. Abdou's research spans reactor safety, thermal hydraulics, and next-generation power plants. He's worked internationally solving tough nuclear challenges with hands-on experience. What sets him apart? He explains complex science in simple, clear ways. Dr. Abdou believes everyone should understand nuclear basics. It's part of our modern world. He's passionate about replacing fear with knowledge, showing that nuclear technology is governed by solid science and engineering. By learning from experts like him, we see that science is a tool. Its impact depends on how we use it. Thanks to Dr. Abdou, we can explore nuclear power responsibly and safely. His insights help keep nuclear energy clean and distinct from weapons. Let's dive into the science with his guidance. What is uranium? It's a heavy element on the periodic table, symbol U, packed with protons and neutrons. This makes its nucleus unstable, key to its power. Uranium comes in isotopes, like different models of the same car. The two main types, U-238, over 99% of natural uranium, and U-235, less than 1%. U-235 is fissile. It can be split easily, releasing huge energy and more neutrons, creating a chain reaction. U-238, on the other hand, doesn't split as easily and can't sustain a chain reaction. That's why U-235 is crucial for both reactors and bombs. But since it's so rare, we need to increase its percentage in uranium. This is called enrichment. Enrichment is essential to make uranium useful as fuel. Think of it as boosting the active ingredient for energy. The science of uranium's isotopes is at the heart of nuclear technology. Understanding this difference is key to knowing how reactors and bombs work. Next, let's see how we make uranium more energetic. Onward. Natural uranium is mostly U-238, so we need to boost the U-235 content. This is uranium enrichment. Imagine picking out chocolate pieces from trail mix. Enrichment separates U-235 from U-238 on an atomic scale. For reactors, uranium is enriched to about 35% U-235, just enough for a steady, controlled chain reaction. This is called low-enriched uranium, LEU, perfect for safe, reliable power. For bombs, uranium must be enriched to over 90% U-235, highly enriched uranium, HEU. At this level, the chain reaction becomes explosive and uncontrollable. The most common enrichment method uses gas centrifuges. Uranium is turned into gas and spun at high speeds. The lighter U-235 stays near the center, while heavier U-238 moves outward. Thousands of centrifuges gradually separate the isotopes. It's a slow, high-tech, energy-intensive process. The level of enrichment determines whether uranium fuels a city or a bomb. That's why enrichment is so tightly controlled worldwide. Next, what happens to the uranium left behind? Let's find out. After enrichment, the leftover uranium is called depleted uranium, DU, mostly U-238 with very little U-235. DU can't fuel reactors or make bombs, but it's incredibly dense, 1.7 times denser than lead. This density makes DU valuable for armor-piercing military projectiles and for adding protection to vehicles. In civilian life, DU is used as counterweights in airplanes and as radiation shielding in medical and industrial equipment. Its density blocks X-rays and gamma rays, making it ideal for safe transport and treatment. However, DU is still a radioactive heavy metal. The main risk is from inhaling or ingesting DU dust, which can harm the kidneys and increase cancer risk. Handling DU requires strict safety precautions to prevent exposure. It's a practical use for a byproduct, but safety always comes first. Understanding DU shows how nuclear science finds value even in leftovers. But what about the big question? Can a reactor explode like a bomb? Let's clear up that myth next. Stay tuned. Why can't a nuclear reactor explode like a bomb? It's all about fuel and control. Reactors use low-enriched uranium, 35% U-235, for a steady controlled chain reaction, never explosive. Control rods absorb neutrons, letting operators speed up, slow down, or stop the reaction like a precise gas pedal and brake. Bombs use highly enriched uranium, over 90% U-235, packed tightly for an instant runaway chain reaction. No control rods, no safety systems, just a design for explosive energy. Even in a meltdown, reactor fuel isn't enriched enough for a nuclear explosion. Meltdowns can cause steam or hydrogen explosions, releasing radioactive material, but never a nuclear detonation. The physics simply don't allow it. Reactors and bombs are fundamentally different by design and science. Understanding this difference is crucial for public safety. Now, what if a nuclear site is attacked? If a nuclear facility is attacked, the danger isn't a nuclear explosion. At enrichment plants, the main risk is a chemical and radiological release. Uranium hexafluoride gas can form toxic hydrofluoric acid and spread radioactive particles. At power reactors, a direct hit could breach containment and cause a meltdown, releasing radioactive fission products. The result: long-term contamination, uninhabitable land, and severe health risks. Not a nuclear blast. That's why nuclear sites are heavily protected and attacks are considered major war crimes. International laws and protocols exist to prevent such disasters. The focus is always on preventing radioactive releases, not explosions. Understanding these risks helps us appreciate the importance of nuclear security. Next, how do we safely move nuclear materials? Transporting nuclear materials is one of the world's most tightly regulated activities. Nuclear fuel travels in ultra-strong casks, engineered to survive crashes, fires, and water immersion without leaking. These casks have multiple layers: steel, lead, or Du for shielding, and neutron-absorbing materials. Shipments are tracked, escorted, and routed for maximum security. The result: an outstanding safety record with no harmful radioactive releases in decades of transport. Careful planning and robust engineering keep the public and environment safe. Moving nuclear material is serious business. Safety is always the top priority. Now let's talk about staying safe and curious. We've explored the atom, reactors, enrichment, and safety, guided by experts like Dr. Abdou. The difference between a reactor and a bomb is all about physics and design. Nuclear technology has risks, but layers of safety, from plant design to transport, manage them. In a radiation emergency, remember, minimize time near the source, maximize distance, and use shielding. If advised, shelter in a sturdy building, close windows, and stay tuned for official instructions. Remove contaminated clothing and wash exposed skin if needed. Thanks to scientists and engineers, nuclear power is safer and better understood than ever. Keep asking questions and stay curious. Science empowers us to make informed choices. The more we learn, the better we understand our world. Thanks for joining this journey. Keep exploring, keep experimenting, and always think like a scientist. Knowledge is power. Use it wisely. Until next time. In a world flooded with information, clarity is rare. Today, we celebrate a voice that brings light to complexity. Professor Dr. Ali Abdou. His dedication to nuclear science reminds us that understanding is a human need, not just a scientific one. Professor Abdou's work goes beyond academia. It's for everyone who seeks to understand our modern world. In an age of misinformation, educators like him anchor us to reality. His recent efforts to demystify nuclear science are a gift to us all. He's made a complex, often misunderstood subject accessible and clear. Let's take a brief journey to appreciate his impact. We'll explore his career, his outreach, and why voices like his matter now more than ever. The atom is both a wonder and a challenge. With guides like Professor Abdou, we face both with wisdom. Let's begin. Who is Professor Dr. Ali Abdou? He's a leader in nuclear engineering, bridging theory and practice across continents. His career spans top universities and industry, shaping the next generation of scientists. Abdou's expertise isn't just academic. He solved real-world challenges and influenced policy. Returning to Egypt, he became a cornerstone at institutions like the American University in Cairo and Zuwayl City. He's building a culture of scientific inquiry, not just teaching formulas. His influence extends far beyond his students. When he speaks, it's with the authority of decades at the forefront of nuclear science. He's an architect of our atomic age, dedicated to clarity and public understanding. His outreach draws from a deep well of experience, and the world is listening. Professor Abdou recently published an article that made nuclear science accessible to all. He explained nuclear reactors, uranium enrichment, and radiation in clear, simple language. In a time of global tension, his clarity is essential. Abdou's work cuts through political noise, empowering us to separate fact from fear. He opens the black boxes of nuclear technology, showing us its true nature as a tool, its impact shaped by how we use it. By sharing this knowledge, he enables informed public conversations about our future. Science belongs to everyone, not just experts. When a scholar like Abdou writes for the public, it's a powerful statement. Your questions matter. His article bridges academia and everyday life, ensuring knowledge reaches those who need it most. It's a public service we should all value. In today's world, scientific literacy is a survival skill. Sharing clear, accurate knowledge is a humanitarian act, empowering people to think critically and resist misinformation. Professor Abdou's work fills the gaps where fear and ignorance thrive. Nuclear science, often shrouded in secrecy, needs voices like his to separate fact from myth. His explanations help us see nuclear technology as a spectrum, not a single threat. By bridging experts and the public, he strengthens democracy and informed decision-making. Abdou gives us tools to think for ourselves, not just answers. Science is about people, improving lives and building a better future. His optimism in sharing knowledge is a vote of confidence in our ability to learn and reason. It's a unifying force in a divided world. The true legacy of a teacher is the minds they inspire. Professor Abdou's impact is measured in understanding, not awards. He's a beacon of reason, making complex science accessible for the public good. Now the journey continues with you. Seek out his article, read it and discuss it with others. Engage, question and share. This is how we build a scientifically literate society. Inspired by voices like Abdou's, let's champion clarity and education. The universe's story is for all of us to read and write together. Thank you, Professor Abdou, for your service to science and humanity. The light of knowledge empowers us all to wonder and explore. Keep asking questions. The cosmos awaits.